Alright, welcome back to Geometry. We're in Chapter 10, Section 2, Measuring Angles and Arcs. Today's guest lecture by Mr. Renault, ladies and gentlemen. Give it up for Mr. Renault. He's forgotten to turn his microphone on here, but he'll be with you in just a second. Over to you.
Okay. So I forgot to turn my microphone on there for the first few seconds, so I'll just kind of go back and recap. 10-2, Measuring Angles and Arcs. This is one of the major angles, and this comes from the center. So if you have an angle whose vertex is in the center, this is called a central angle. Okay, using the root word center, that's a central angle. Again, they are drawn from the center to the outside edges. Okay, so in this case, the sum of all of the central angles, SUM, the sum of all the central angles is 360 degrees. Okay, so let's say I had this central angle as 40 degrees, and it wanted you to find the larger central angle. Okay, I would just take 360 degrees minus 40, and that would give me a total of 320 degrees for that particular one. Okay. So now in our central angles, we could have, there could be a 90-degree angle there. There could be a 180-degree angle. A semicircle would be 180 degrees. So it just depends on what they give you. Going to be some subtraction from 360. So now let's look at the arcs. Okay, the arcs have to do with part of the circumference. Okay, so if I draw that central angle again, I don't want to do it this way. I want to draw three small ones. Okay, I don't want to do that. Give me just a sec. Okay, so I'm going to draw three central angles. So I have one here. Then I'm just going to draw a diameter there. And then maybe just a little bit smaller one. I'll show you what I'm going to do here in just a minute. I have three types of arcs. Okay? And the arcs are created by the endpoints. Okay, that's an arc right there. That's the one we're going to be looking at. Okay? This is called a minor arc. Okay? This one is called a minor arc. And that's because its arc measure is less than 180 degrees. Okay? So almost like an acute angle. When we think of acute angles, they're less than 180 degrees. Arcs are the same way. Okay? So now, let's look at the one over on the right-hand side, and I'm going to label from here all the way around here. So it's not the little piece, it's the bigger piece. That is a major arc. A little bit better A there would be good. And a major arc is greater than 180 degrees. and it's also less than 360 degrees. Okay, because 360 degrees would be a full circle. Okay, so now let's look at our third example. And I'm going to go from this distance here. And because I'm going halfway around my circle, this is called, oh, I don't want that. I want to get some pen. Okay, this is called a semicircle. And this one equals 180 degrees. Okay, so three types of arcs: minor, major, and semicircle. So let's do an example with one of these. Okay, so let's take a look at our work here. We're going to look for GH first. So I'm going to highlight GH here in yellow. And when we're finding an arc that is a part of a central angle, then it's the same degree as the central angle. So the central angle for this one would be GKH. So my total is going to be 122 degrees. Okay. So let's get rid of that one. And now let's take a look at GLH. Okay, G, and I'm going to go in order, L, and I'm going to go all the way around to H. So I know, in this case, that that's everything except 122 degrees. So I'm going to take 360, and I'm going to subtract 122 degrees. And that comes out to be 238 degrees. Let me get some boxes around those. Okay. So let me get my eraser on that one. I'm going to have to redo my H, J, and L. I didn't plan that very well. Let me do that real quick. Okay, so let's look at the last one. Let's do another color. So we're going to go G, L, J. Okay, G, L, J. We know that goes from the endpoints of the diameter. So this one's pretty simple. We know that makes it a semicircle, which is going to make that arc 180 degrees. All right, let's move on. Okay, so now let's look at actually measuring the length. Okay, so what portion of the circumference is this? So I want to find the measure of length AB. Okay, before we were finding the degrees of AB. Now we're going to find the actual measure. And at the top of page 695, it's just a ratio. The ratio of the length of an arc to the circumference of the circle is just a ratio to the degree measure of the arc, to 360. Broken down, it is the arc length is equal to the ratio to the actual degrees of the circle times 2 pi r. Okay, and that 2 pi r should look familiar. That's the circumference. So what we're going to do to find the actual length of AB is x over 360 times 2 times pi times the radius, which in this case is 4. I'm going to clean that up a little bit. 2 times pi times 4 is going to be 8 pi. Okay. And so in this case, we're going to round to the nearest hundredth. So now I'm going to have x over 360. Excuse me, that's not an equals. X over 360 times 8 times 3.14. Okay, so that's x over 360. I've got my calculator out now. Times 25.12. So x equals whatever 360 times 25.12 is. And that comes out to be and that comes out to be not, oh, you know what I forgot to do? I totally forgot to replace. All right, let's look back. I knew that number wasn't right. I forgot to replace my x because I know what my angle is. My angle is 75 degrees. So let me go back. Good thing we work in pencil, folks. So that's going to be 75. All right, so 75 over 360 equals 2 times pi times 4. And so let me figure this out real quick. All right, so we've got 75 times 25.12, which is 1,884. And we're going to divide that by 360. Divide by 360. And that gives us approximately 5.233. And they have asked us to round to the nearest hundredth. So our answer for arc AB's length will be approximately 5.23. Okay, sorry for the confusion on that 75. Just made a little bit of a mistake. All right, so that should do it. About 12.5 minutes on Chapter 10, Section 3.
Thank you very much, Mr. Renault. Remember to like and subscribe to Mr. Renault's channel. You can find him on the YouTubes at David Renault. All right, that's all the fun we can have for today. See you later.